let's go ahead and apply whether or not we can ignore the x, the minus x component in a rice table. Let me just kind of give us an example of something that we're working with. Let's say I have an OHA, which is a weak acid, and I'm going to react that with water. Let's make this aqueous, H2O liquid, and have that in equilibrium with, let's say, H3O plus, so our hydronium, aqueous, and I don't know, our A minus, aqueous. So if I gave this to you and you wanted to start Ka for this, you would look at it, that's an A, you would look at it and you'd be like, okay, so my HA is going to be like some initial concentration, let's just make it like 0.10 molar. And then my water I do nothing with. And then if we were just starting it off and just going on the assumption that there was no acid in there before I added my HA, then I would have nothing on my acid and nothing on my conjugate base. And just let's remind ourselves that this would be a weak acid, and that means that water is acting as our weak base. It's the proton acceptor. And on this side I have my strong acid and my conjugate base. So this is going to be a weak base. Cool. Then we go through and be like, okay, so minus x here, and then plus x, and then plus x. And in the end we'd have this expression that was like just x and 0.10 minus x. So the quantity that we're asking if we can ignore is this quantity. And a way to think about that is if my delta x is going to be like 0.0004, then that's really not changing my 0.10 that much, right? And so it wouldn't even like register. But I can't just ignore x, otherwise I'd be saying my n concentrations here are 0. So specifically the thing we're looking at is, can we ignore this? And then I told you in the previous video that the way we can look at that is say that we want an expression, or to look at the magnitude of, oops, I don't want to write anything in there, magnitude of the initial concentration of our acid or our base divided by the equilibrium constant. And that we said if this is greater than or equal to, actually, let me write that as greater than equal to. This is greater than or equal to these two quantities. I'm sorry, greater than or equal to, my train of thought just jumped off the train tracks. Greater than or equal to, and I said let's go with 10 to the number of sig figs, right? So in this case we'd have 2 sig figs, so 10 to the 2. So if this quantity is greater than or equal to 100, then yes, I can ignore it. And I talked about, because this is in the hundredths place, right? So greater than or equal to means that I'm not going to see a change. So now I asked you, now I'm going to give you some practice with that. And what I want you to do is to pause this and come back. And I've given you a list of initial concentrations and of their K values. So let's see what you come up with. Come on back. Okay, so for this one, the concentration, and let's write this out, concentration is 0.100, and this is going to be divided by 1.4 times 10 to the negative 4. And for this I get a value of 714. Let's see, I have 3 sig figs here, 10 to the 3, well that's 1,000. So what that tells me is when I do my rice table, I'm going to have to go forward and do the entire gosh darn thing. I cannot ignore that change in x. I cannot ignore the minus x for that one. And then for the next one, this 0.075, I'm just going to repeat that process, and I'm not going to write everything out. But for this one, I get 2.6 times 10 to the 12th. Let's see. I want to know, I have 3 sig figs here. Is this greater than question mark 1,000? Yeah, it's considerably greater than 1,000. So for this one, we can definitely ignore the change in x. And now, so we've seen this is a teeny tiny k. And one of the ways to kind of mentally predict what's going to come out of this is that if I have, just say, 10 to the negative 2, so let's say like 4.0 times 10 to the negative 2 divided by 10 to the negative 14. Without putting anything in my calculator, what this thing becomes, I have a negative exponent on the bottom. What's going to happen is that negative is now pulled up into the top. Let me write exactly what I mean by that. 10 to the 14. So this thing here would actually give me 4 times 10 to the 12. And I haven't put anything, 4.0 I should say, I haven't put anything in my calculator. Didn't need to. Well, what was I looking for this to be? Is it greater than, let's see, I have 2 sig figs, greater than 100? Greater than or equal to 100? It most definitely is. So one of the first things you can look at is just evaluating that. And this here is just by definition for mathematics. If I write 1 over 10, the way I write that is 10 to the negative 1. So if 10 to the negative 1 lives in the denominator, it's going to become 10 to the 1. It's like taking the inverse, if you will. All right. So now coming back to here then, I have this 0.05. Oh, I got lots of sig figs. So this needs to be bigger than, let's see, that's 100, that's 1,000. Needs to be larger than 10,000. And I'm dividing by a rather large, so rather large k. That tells me my delta x is going to be pretty small. And let's see what I get out of that. I, in fact, do get a small product of that. I get like 3.33 times 10 to the negative 11. My prediction was that with this k value being so large, that even with it being that large, I am going to have to include it. So that means it cannot be ignored. And that's just kind of looking at my k values. Now this one here, I get a little bit double checky on. Let's see, I have a 10 to the negative 4. I'm dividing by a 10 to the negative 7, so I know at least between those two, I'm going to end up with a 10 to the 3rd. Well, what I'm going to have, I want something that's on the order of magnitude of 10 to the 3. And what does it need to be larger than? It needs to be larger than, I have 2 sig figs. So is it larger than 100? And 1,000 is definitely larger than 100. So that is doing the like mental check without doing any button pushing. And what do I get? I get that this one here is 160. Is that right? That's, oh, 1.2, yeah, so it would be smaller. So that's why the approximation is good in your head, but let me show you why it's 160. That actually caught me off guard. So I have 1.2 divided by 7.5, just looking at the numbers that are in front. And what I was doing in my head over here was the 10 to the negative 4 times, this is on the bottom, so the 10 to the 7 is going to pop up as positive. So this is going to give me, let's see, 1.2 divided by 7.5, which is going to be smaller than 1, and I get 10 to the 3rd. So this is actually the 10 to the 2nd, which is going to give me that 160 rather than 1,000 something. So I look at that, and it is, this would be greater than 100. So even my rough idea of it came out correct. It was just a magnitude smaller than I anticipated because I didn't look at the whole number, which is fine. Worst case scenario, you can always throw it in your calculator, but it's good to have an idea. Let's see, 7.3 times 10 to the negative 6, and I have now a small k. What am I going to get? Let's write this out. Let me write it down here. I'm starting to get too cluttered. So I'll have 1.2, I'm sorry, I already did that one. 7.3 divided by 4.6. Let's look at my exponents. I have 10 to the negative 6 on the top 10 to the negative 10 on the bottom, so that's going to become 10 to the 10. 7.3 divided by 4.6, so this is going to be a number greater than 1. Not much. It's not going to be 2 yet. So it's going to be like 1 point something or other. And then what's my exponent? 10 to the 10 minus 6, 10 to the 4th. What do I need this to be bigger than? Well, it needs to be bigger than 100. And I can tell you right now, without putting that in my calculator, that is indeed going to be greater than 100. And the actual value I came up with was 1.6 times 10 to the 4. So what does that say? We can ignore it. Cool. Last one. Now, I've been giving you this kind of exponent trick to help make your life a little bit easier. Do that one. What do you think? See what you come up with, and then come back. All right, let me do it. 9.1. And I'm just leaving off the sig figs for now just to kind of get a good estimation of what's going to happen. I have 10 to the negative 2 times 10 to the 4. So let's see, almost 3-ish. 9.1 divided by 3.2, that's almost 3. I'll go ahead and rewrite it. Divided by 3.2 times, let's see, what do I get? 10 to the 2. So something in the hundreds, and what did I need this to be? I need this to be like, I have 3 sig figs. Is this greater than, let's do a question mark, is it greater than 1,000? Well, at best, I'm at 3, and I'm going to be just shy of that. That's not greater than 1,000. So that means I cannot ignore it. Let's reveal the final one. Nope, I cannot ignore it. So there you have it. I know that for many of you, these approximations make you uneasy, but do keep in mind that it is a huge time saver because we are going to be doing a lot of things that are going to be in quadratic form. So if you can save your time by approximating things, you're much better off for it.